Um, so again, that's one thing. By the way, you can also get what are called achromatic. So achromatic. So ag, like, uh, basically means non or not chromatic. So like amoral, an amoral person is a person that doesn't have any morals. No morals. Well, achromatic lens, no chromatic aberration on the lens. And you can have these multiple lens systems that effectively do that. You can actually buy single lenses that do that. And in that case, it's not really glass or plexiglass. And with plexiglass, they can lay it down layer by layer, and they can change the index of the lens as the light goes through the lens. So on one side of the lens, it starts out at a certain index, and then when we get to the other side, that index is changed. Well, that's much more expensive because it's harder to make that sort of a lens. And those can be really expensive lenses, but they're more just single lenses at that point. And again, if you're into photography, that's, I like photography. I'm not that into it that much, but I like it. If you want to know what the focal length of the lens is just physically, so you've got some index for the lens, call it 2. And you've got some index for the material that's on either side of the lens, n equal 1. Now, in most cases, or in the generalized case, that's air. We're just going to say that's 1. But the focal length of that lens, so 1 over the focal length of the lens, would be the index of the lens minus the index of the surroundings. Again, in your book, you just list that as 1, so it's effectively saying it's air. And then you've got times 1 over the radius of curvature of the first surface, R1 for this surface, R2 for that surface, and then plus 1 over the R2. Now, there is some conventions as to when you put those as positive and when you put them as negative. And I don't remember because, again, I don't give problems where you're actually having to use that equation to calculate a focal length. But if you knew whatever the convention was, when is R positive, when is it negative, you could write these numbers in here for all of that, and you could calculate the focal length of the lens at that point. If it's a converging lens, it's already end up as some positive number. Diverging lens, it already end up negative. But if this is just a 1, then you got index, which is bigger than 1 for the glass or the plexiglass, whatever the lens is made out of. And so the n minus 1 is going to be some positive number. And it just depends on what's the radius of curvature, is whether the focal length is positive or negative. But what if this is not air? What if it's water? So if the N2 is, say, 1.5, that's standard glass, and this is 1.33 for water, you got your converging lens in water, what happens to the focal length? Does it change compared to what it is when it's out in the air? If you just look at this, you'd have for air, this would be 1.5 minus 1. For the water, this would be a 1.5 minus 1.33. Same radius as curvature. You hadn't changed the radius of curvature. So this factor in your equation is going to remain constant. But if I make this closer to this index for the material of the lens itself, this term gets smaller. It's a smaller difference. But if this is smaller, what's happening to F? It's getting bigger. So you take your converging lens, your magnifying glass, you look through it, find its focal length out in air, you put it under the water and then measure the focal length of that lens, it's going to be a longer focal length. Now that's one way to look at that, to reason through that. Is, looking at my equation, what's happening to these two numbers. The other way, think of your converging lens. Well, light coming in parallel is going to go to the focal point. Standard thing. If this is air out here, air on both sides, okay, it focuses at, say, that point, focal length for air. But if this is water instead of air, it's going through here. As it goes from the water to the glass back out into the air, you do it exactly. You'd have to look at refraction at both the water glass side and then the glass water side. If you just think of the bending going from water to glass, or the other way, either way. So if you had water here, glass here, here comes the ray in. You go into a bigger index, and so you ought to bend toward the normal this way. So here's my theta 2, here's my theta 1. Looking at Snell's law. If this N2 is closer to N1 compared to air, so going from water to air, you bend at a certain angle. Going from water to glass, it's a bigger difference, or it's a smaller difference in the end values. So the thetas are going to be different. The closer those ends are together, the less the bending is. Less they're going to deviate from their original path. And so the light coming in the water going to the glass, it's not going to bend as much as it does when it goes with the air. And so the focal point then is going to be somewhere out here. It's a bigger focal length if you surround it with water compared to if you surround it with air. Now this equation just allows you to look at it mathematically. This difference gets smaller, and that's reciprocal to the focal length, so focal length ought to be bigger at that point without changing whatever the R values are. But then conceptually, in Snell's law, if the two indexes are closer, the two thetas are closer to each other, which means it's being bent less or deviated less. And therefore, if it's deviated this much for air, it ought to deviate less when it's in water, so the focal length is moved further away from the lens itself. That's depending which way you want to look at it. But that would be how you could approach that sort of a question. What's happening to the focal length? Yes, the focal length depends on the radiuses, but it also depends on the index of the lens itself and what's the index of the surroundings. What's on either side of the lens. Okay, so we've got lenses, we've had mirrors, And we talked about double lens systems. What else is that? Admirations. And really, as far as chapter 33, that's it. So, since we don't have a lab today, I know y'all are all just gonna really object. I'm gonna give you a quiz, and the rest of the time, if you've got particular questions,